Hello, everyone. Welcome to Big Browser, attacking and defending the process that knows everything. My name is Andy Thompson, and I am the Offensive Security Research Evangelist here at CyberArk Labs. And I don't have a whole lot of time, so we're just going to get straight to business. We're going to be talking about how the Chromium engine, the code base under the hood running Chrome, Microsoft's Internet Edge, Komodo, Brave, Opera, a ton of different browsers are inherently vulnerable to attack and how they will ultimately expose secrets to threat actors. Well, what secrets might you be saying? Well, there's obviously the passwords, but there's so much more. There's cookies and session tokens, along with credit card numbers, addresses. There's, again, a ton of information that's at stake here. And I'm going to show you what I like to say 5 ways to skin a cat here. This is really kind of our agenda of what we're going to be walking through today. I'm going to show you as a standard user how we can steal passwords and cookies through things like keyed in data. We'll talk about how inline attacks can be used to harvest secrets. And then we're going to really talk about the Chromium specific threats, such as the fact that passwords are stored locally on disk, as well as easily accessible within the memory. And last but not least, if you just simply ask the browser, it's incredibly easy to steal sensitive information. So with that said, let's get started and talk about our first method of secret stealing, and this is keylogging. You're probably familiar with keylogging before. This is, the typical stealing passwords one keystroke at a time. And there's 2 different styles of keylogging. First, there's the traditional hardware-based, the little dongle that sits between the computer and the keyboard. This is one method, but there's a new style that's more covert. This is the OMG cable. It masquerades and functions just like a regular Lightning or USB-C cable, but it's broadcasting its own pirate Wi-Fi signal that allows a threat actor to not only intercept and receive keystrokes, but also send keystrokes as well. Now, there's another type of keylogger. It's the software-based keylogger, and there's a ton of free and open source keyloggers out there. They're also just about in every single command and control framework out there. And a lot of the apps that you may not be aware of, like TikTok, for example. TikTok's in-app browser supports JavaScript-based keylogging. So I don't know why you would ever log a username or password in the in-app browser, but just be aware those keystrokes can be logged. All right, so I'm going to show you a really quick and dirty keylogging example. We're going to be using the basic Windows keylogger, okay? What we'll do is just go to a website, type in our username, type in our password, and our keylogger will log the individual keystrokes, okay? So now that we have successfully logged in, all we need to do now is stop the keylogger process and then go review the keystrokes that we typed. Okay, so now that we've stopped the logger process, we go and review the keystrokes, and here you have it. Positive horse battery staple. What is that? Well, it's a reference to a very nerdy comic, XKCD, which talks about how to create a very strong password. And if you'll notice here in the bottom left-hand corner, it says correct horse battery staple, not positive horse battery staple. Unfortunately, I made an error, and I already recorded my video demo, so tough. We're just going to go with positive horse battery staple, okay? So how do we go about protecting ourselves from keyloggers, right? Well, there's several ways, 3 actually, that I'm going to recommend. The first is through having some sort of hardware device detection. There's several applications out there that will monitor the system for keyloggers, such as GhostPress or KL detector. You also have application control. You can't have a keylogger running on your system, a software-based keylogger, if you've got aggressive application control that doesn't allow that keylogger process to run. Makes sense, right? And then the other is really simple, password managers. If a password manager, even like the weakest password manager available, like Chromium's password manager, if it's injecting the password into the property field rather than actually typing out the keystrokes, well, then it will mitigate the risk from a keylogger, but not other methods. Another method that can be used to harvest those sorts of credentials would be through inline attacks, otherwise known as adversary in the middle. Again, this is more applicable to the operating system in general, but a typical inline attack is like this, all right? You have your standard server client communication going backwards and forwards, but when you have an attacker in the middle, they're able to intercept and even, manipulate that data going back and forth between the client and the server. And there's two ways that we could go about stealing secrets through this method. The first would be at the network layer, using some sort of a proxy server to intercept the network traffic. But then there's another type of way, and it's just using social engineering. This here is Trusted Sec's social engineering toolkit. Dave Kennedy and crew were able to get SET installed into the base image of Kali Linux. So I just spun up a fresh VM here, launched SET, and what we're going to do is we're going to use SET to make a phishing site. There are tons of built-in templates here within SET. You could even clone your own website if you so chose, but we're spinning up an instance of X or Twitter, okay? So now that the web server is running, all we need to do is convince our mark to go to that site, whether it's through social engineering, like phishing, or maybe a DNS poisoning attack. It really doesn't matter. But once you've convinced your user to go to that website and authenticate using their username and password, and even if they're MFA challenged too, once they have attempted to log on like they've done here, all an attacker needs to do is go review the logs of their server, and there you have it, folks. Positive horse battery staple. So how do we go about protecting against these sorts of inline attacks, whether they be network or social engineering based? And there's a couple of ways, really. The first would be through encryption methods. Simply put, by making sure and analyzing the TLS or SSL certs, you're ensuring that you know who you're talking to. So you know that you're talking, in this example, to the X servers or Twitter servers instead of some fly-by-night phishing site, right? Also, VPNs can provide some value. They do a really good job at protecting from HTTP, that unencrypted traffic. But TLS has basically taken over the internet. So like 99% of all web traffic is encrypted. So that's why these radio advertisements saying, oh, protect yourselves from hackers using a VPN, and it's not entirely all true. But what is really, in my opinion, the most powerful way to prevent these sorts of inline attacks is end user awareness training. So many people think that, oh, the end user is the weakest link, but I disagree. I tend to think that empowering your end users with end user awareness training takes them from being the weakest link to the front line of defense. And so making sure that they're aware of these style of social engineering attacks and making sure they're monitoring their servers that they're actually talking to goes a long way in preventing inline attacks. All right, moving forward, we're going to talk about the Chromium specific vulnerabilities. And I say vulnerabilities because there's not actually a vulnerability per se, but there's nothing that the browsers believe that can be done to protect against this. And we're going to first talk about secrets stored on disk, okay? Chromium has this password file, right? This password file is stored locally on the machine, and it's encrypted. So ideally, nobody should be able to read it, right? However, the private key, it's actually stored as an environment variable running as the logged in user. So as long as you're logged in as the end user, all you have to do is call the environment variable up and use that to decrypt the encrypted file. Again, incredibly easy to do. So if you pop a end user's machine, yeah, you just get the encryption key, and you're off to the races. But also, if you pop a domain controller, you get the master DP API decryption key, and you can read the password files of any Chromium browser on your domain. So that just makes it even more scary, right? So here is the file path of the password file. And so this is the file, folks, that you really want to protect from applications like these. Chrome Pass, Lasagna, Hack Chrome, all of these do a really simple job, and they do it really, really well. I'm going to demo Hack Chrome here. All it does is this. It reads the password file, it pulls the decryption key from the environment variable, decrypts the file, and spits it out on screen, folks. It's literally that easy. I know. So let me show you how easy it is to also protect your machine from this type of password file attack, okay? Really simple. All you got to do is make sure that only the browser can read that password file. So again, here is that password file that we have to protect. Only Chromium's browser should be able to read that file. However, while Chromium is doing its version update, it will also take a backup of that password file. So if you really want to protect it, you need to do a couple of things. You need to create this policy that implements wildcards as well, but also a couple other things. Again, you want to make sure that nothing can read it, but also you want to make sure it can't copy it, make sure you can't rename it or move the file, or even like zip it up. Compressing it might take it out of policies. So again, you only want the browser to read that file. That is it, okay? So moving on, and in a similar vein, we're going to talk about how the browser exposes the secrets in the process's memory, okay? This is how it works. Simply put, if you know what you're looking for, it's like finding a needle in a haystack, okay? I'm going to show you with the understanding that we know what that needle is, our password, positive horse battery staple. I'm going to show you where in the memory, in clear text, that password is stored. I'm going to use this program here called Process Explorer. It's this application, again, running as a standard user, allows you to analyze the memory of other processes running on the machine. We're going to look through some of the strings and see if we can find anything interesting here. So again, we know what our password is, right? Positive horse battery staple. Knowing that, we're going to go search through the memory, and lo and behold, take a look, folks. There, clear as day, in clear text, again, as a standard user, we're able to see positive horse battery staple straight up in the memory. All right, so let's jump straight into the demos. I've got 3 demos that will progressively build on what we're talking about today. In our first one, we are going to launch Chrome's password manager, expose the credentials in memory, and then use our malware to harvest those credentials. So again, using Chrome's built-in password manager, by just launching it, you're literally loading every credential into the process's memory. So now, using our custom crafted malware, we analyze, we find that Chrome exe process, we read the memory and spit out 4 usernames, passwords, and URLs. It's just that easy, folks. All right, moving on to our second demonstration. This one, we're not going after passwords, we're going after cookies, okay? So what you see here on the right is our user. They're authenticating with their username, their very, very complex password. Heck, they're even using multi-factor. Now, we're using SMS, and you shouldn't be doing that in the first place, but honestly, it really doesn't matter. It doesn't matter if you're using SMS, Radius, SAML. It doesn't matter because this is all post-authentication. Once you've authenticated, even with MFA, that cookie is in memory and it's ripe for the theft, okay? So now that we've authenticated, we're running our custom malware that, again, detects the Chrome process, analyzes the memory, and finds the cookies. In this circumstance, we found 4 different cookies. So what an attacker would now do is copy and paste those cookies onto their attacker machine, and then they're done with the victim's machine. So what we're going to do now is we're going to use a browser extension called Cookie Editor to create our own cookie. There's easier ways to do this, but I just wanted to kind of show you. What you do is you basically copy and paste the properties from your cookie file into the browser extension. Now, I'm going to fast forward this a little bit, but suffice to say, once you have entered in the value and the expiration and everything, all you need to do is save the cookie file, reload gmail.com, and boom, you have hijacked the session. It's literally that easy, folks. As you can see, we have successfully hijacked our victim's Gmail session. Okay, now we're on our third session hijack demo. And this time, we're not going after Chrome EXE, we're going after MS Edge EXE. That's right, Microsoft's Chromium-based web browser. This time, we're going after Microsoft's Office 365 OneDrive product. So as you can see here, we are logging in with our secure username and very complex password. I decided to skip over the multi-factor this time because, again, it doesn't matter. Regardless of whether you've used MFA or not, the cookie is deposited after the fact. So again, now as a standard user, we're going to run our custom crafted malware. And this time, it's not looking for Chrome, it's looking for MS Edge EXE. It found it. It's analyzing the process, seeing if it can find any cookies, and oh boy, does it. O365 actually uses a lot of different cookies. I mean, a lot. And so rather than importing and manually creating all of them, what you can do is really just, again, import them, compress them into an encrypted file, and then import all of them at the same time into the web browser extension, okay? So I'm just going to go ahead and skip all this in the demo here. Let's see, probably about right here. So, yep. So we've gone ahead, we've imported them in. All that we need to do now is just reload the page. And so let's see if we can find that URL here. There we go. That is the URL that we're going to need to hit in order to access our hijacked session. So we just copy and paste that. Once we do that, we're in like Flint. All right, so here you go. Take a look. Hijack complete. We have successfully taken over this session of our victim's O365 session. We're able to peruse and ultimately exfiltrate all this juicy, sensitive information. And the thing is that we didn't even have to go to all that effort. We could have just bought the credentials outright anyway. This here, folks, is the Genesis Marketplace, an underground marketplace for the buying and selling of usernames, passwords, but right here we're looking at cookies and session tokens. That's right. These are from all over the world, and I've just got a couple that I want to show you. This one here, $59, gives you access to all sorts of things like Tumblr, but Office 365, Microsoft Live, Amazon, Google, Twitter, a ton of stuff. 59 bucks, folks. Here's another one here. This one here is $24, but it gives you access to Box, Dropbox, Android, tons of stuff, right? Here's another one here. This one, though, 17 bucks, has browser fingerprints. That's pretty darn cool, too. So luckily for us, the Genesis Marketplace is no more. A collaboration of law enforcement agencies all over the world as part of Operation Cookie Monster shut down the Genesis Marketplace. However, there are a ton of other marketplaces on the dark web that do buy and sell these cookies online. So we're not out of the woods yet. But let's move on and talk about how to mitigate and protect against these style of in-memory cookie harvesting attacks. What you got to do, folks, is really simple. You got to make sure that the only process that can read the browser's process is the browser. I mean, it's pretty simple. Only Chrome should be reading Chrome's memory. And this can be done in a couple ways using CyberArk's Endpoint Privilege Manager. What you'd really want to do is make sure that only binaries that are signed by Google, for example, are allowed to read Google Chrome's memory, okay? Also, you want to make sure that the original file is chrome.exe or msedge.exe. You want to make sure that the malware hasn't been like renamed to Chrome to try to circumvent these controls. So that's one of the definite ways to make sure that your memory is protected by only allowing the browser to access that memory. All right, last, and I don't know, this is pretty interesting here. This is by just simply asking the browser in a particular way using command line arguments. It's incredibly easy to find secrets, okay? So this isn't anything new. This was actually discovered back in 2018 by this person by the name of Alex in Australia, actually. They were able to figure out that using the remote debugging port command line argument extends the capabilities of the browser by a significant margin. It ultimately allows a Python script to be run that will then just export all the cookies into a file. I mean, it's that easy. This, folks, is Cookie Crimes, and this is a very, very simple demo of Cookie Crimes. What you got to do is you got to launch the Chromium browser with the remote debugging pipe command line argument, okay? You could do this headless with no GUI, but that kind of makes for a boring demo. So we're going to go to KLI.org, or the Klingon Language Institute for any of you Trekkies out there. But now that we've got our Chrome process running in remote debugging mode, all we have to do now is run our Cookie Crimes script. So what it's doing is because Chromium is running in remote debugging mode, it's requesting the cookies and it's just porting them out to JSON. So once the script is done running, like it is now, all we need to do is just open up Notepad, copy and paste the JSON into our browser extension, and we've hijacked the sessions of that machine. So there you see it, folks, plain as day. You got your cookies in clear text and JSON format. I'm not going to go through all the effort of doing the actual session hijacking, but suffice to say, you see that? That's enough for enough to show you that the attack works. So what do we need to do to protect against this type of attack? Well, we got to make sure that certain command line arguments aren't executed. There are legitimate reasons why these command line arguments might be used if you're a sysadmin or a developer or something like that, but our standard users don't need to use these command line arguments. This same concept applies with lulbins, or living off the land binaries. Sysadmin might want to run certutil, but standard users pretty much don't need to. So what I would recommend is these three particular command line arguments: remote debugging port, remote debugging pipe, and headless. There's no reason our standard end users need to be using these arguments. But EPM allows for you to have granular controls over your processes. So maybe you want to allow Chrome to run, but certain arguments block. EPM can do it. Maybe you just don't want to allow certain applications to run at all. EPM can do that. This is really why Endpoint Privilege Manager's application control capacity is incredibly powerful. So there you have it, folks. Those are the 5 ways to go about skinning our cat. 5 ways as a standard user someone can steal browser secrets. Okay, so let's as a review, we talk about keylogging as a way. We talk about how inline attacks allow you to intercept communications and hijack secrets. But then you also have the fact that Chromium stores credentials on a very weakly encrypted file. Okay, it's very easy to unencrypt and read that password file. It's just as easy to read the memory of the browser process. And again, these credentials, these cookies, these secrets are stored in clear text. And last but not least, if you just ask the browser with the correct command line arguments, it's incredibly easy to steal browser secrets. So what do you got to do to protect it? Again, as a review, you got to deny, deny, deny. Make sure that you're denying these rogue processes the ability to read that password file. You need to be able to deny processes from reading the browser memory. You have to really make sure that you're denying access to rogue command line arguments that can be abused. These are the things that, again, are built into CyberArk's Endpoint Privilege Manager. These default policies can be flipped on with a literal flick of a switch. Well, figurative flick of a switch. And that's all you need to protect your browsers because, again, they're inherently not doing a good enough job. So with that said, thank you so much for listening to my presentation today. I hope you learned something. I hope you were entertained. And I hope you have a great rest of your day. Thank you.